Yeah, is my screen visible to you? So, chemical reactions and equations. Let's have a quick revision from the starting. Some points we discussed in the previous class, but our class is like so many days back. So, I think it is better to read from the starting. NCRT, each and every point. So, take out your book, first page. So here in the first point, it is given, consider the following situations of daily life and think what happens when. For example, if they are saying that milk is left at the room temperature during the summers, then what happens? So like they are saying that an iron or iron tawa or pan or nail is left exposed to the humid or moisture rich atmosphere, then what will happen? And grapes that get fermented, food is cooked. So actually what they are saying here about these all aspects, that there are some chemical reactions that are being taking place in all these things. There are some chemical reactions that are being taking place here. So now here underline this point, chemical equation. So chemical equation, they gave a simple reaction here. For example, when the magnesium ribbon is burnt, this is important, underline this. When the magnesium ribbon is burnt in the oxygen, it gets converted to what? Magnesium oxide. So in the reaction also you can see that magnesium plus oxygen, if these will be my reactants, if these are my reactants, then it form my magnesium oxide. Magnesium oxide is my product here. Okay, so is, am I clearly audible to you? Okay. Okay. If there will be any problem, then you can tell me. So the magnesium and oxygen here are the reactant. The new substance which is formed here. What is the new substance formed here? Magnesium oxide. So that is the product formed here, produced as a product. So the word equation shows the change of the reactants to products, obviously through an arrow placed between them. Obviously arrow is placed between them. Here you can see this is the arrow which is placed between the reactants and products. So we know that reactants, they are written on the left hand side, and similarly products are placed on the right hand side. So here we can see a simple point is given, writing a chemical equation. So how you can write a chemical equation? So here for example, a chemical equation is given, Mg plus O2 will give you MgO, that is magnesium oxide. So next is a balanced chemical equation. Balanced chemical equation. So the total mass of the, underline this point, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. That kind of the chemical equation, I will call it as a balanced chemical equation. So what is my balanced chemical equation? It is a equation where the, it is a equation where the total mass of the elements which are present in the products, that is equal to the total mass of the elements present in the reactants. That kind of the, yeah, yeah, of course, yeah. Mass should be equal, okay, both sides, reactant as well as the product. That type of chemical equation, I will call it as a balanced chemical equation. Clear? So, example they are giving you here, underline this example, zinc plus, have you opened your NCERT book also? Yeah, open it and see the points, and the points that I will tell you to underline those, okay? Just put a star mark here in this reaction. Zinc plus sulfuric acid will give you zinc sulfate plus hydrogen. So what is the symbol of zinc? Zn. Zn plus sulfuric acid is your H2SO4. Remember right here, it is a strong acid. It is a strong acid. This is one additional question from here. Strong acid. So it will give you what? It will give you ZnSO4. What will become here? This is Zn, this is SO4. So you will get zinc sulfate plus which gas is evolved? This is important. Which gas is evolved? H2 gas. So as one thing you can see here, that this reaction is my balanced chemical equation. This reaction is my balanced. Why? See, number of zinc in the, tell me how many zinc are there in the reactant side or in the left hand side, and right hand side. And hydrogen also same, both the sides. Sulfur oxygen also same. So is this a balanced chemical equation? Yes, it is a balanced chemical equation. In the table also same thing has been shown. In the table also same thing has been shown. So they just showed that zinc, that is how many number of atoms, zinc atom 1 in the left hand side, and how many number of atoms in the product, that is the one zinc is there. So same thing, H is 2 here, reactant side, product side also 2. Okay, so this table simply showing this thing. And next is the, let us try to balance the chemical equation. For example, they give you a simple practice question here, that you have a chemical equation. Let's say I have Fe, iron. Fe is the symbol of what? That is the symbol of iron. And its reaction has been shown with the H2O, that is your water. So if it will give my Fe3O4, oxide of this iron, plus H2. So they are saying what? They are saying that just balance this equation. So what are the steps to be followed here? See, step number 1, to balance a chemical equation, first draw boxes around each formula. So what you have to do, simply here each formula, this is the iron, this is the H2O, I have to do what? I have to draw boxes around each formula. As you can see here, boxes have been shown. Step number 2, what we have to do, list the number of atoms of different elements present in the unbalanced. Then you just list that how many number of atoms of different elements they are present in the unbalanced equation. So I simply make a list here. Here I will write what? I will write here the elements. So what is the first element that I am having here? What is the first element that I am having here? So first element that I am having here is my, you can see here, that is my iron. Okay, so I will write here iron. Second element I am having here, that is my hydrogen. Third element that I am having here, that is my oxygen. Clear? So tell me, how many number of atoms of each of these elements are present in the reactant side? Hmm. Oxygen atom 1. Okay, next, products. In the product side, tell me. Yeah, so that is the thing here. So step number 3 is our what? In the step number 3, this is the thing that we have to do. We have to just list the number of atoms of different elements. Next, step number 3, it is often convenient to start balancing with the compound that contain the maximum number of atoms. So it is convenient to start balancing from which compound which contain the maximum number of atoms. So it may be a reactant or a product, or of course it may be a reactant, that compound which is containing the maximum number of atoms, that may be a reactant, or that may be a product. So in that compound, select the element which has maximum number of atoms. So using these criteria we can select Fp3. Tell me which one is having maximum number of atoms. Of course, which one here? Compound, complete compound I am asking na. Yeah, complete compound you have to select now. Simply this was my reaction. See, this was my reaction. Fe plus H2O will give me Fe3O4 plus H2. This was my reaction. So what I have to do, I have to draw boxes around each formula. So in this way I draw what? I draw the boxes around each formula. And after that I have to list the number of atoms which is present there, number of atoms of every element I have to mention. And then next I have to select the element which has the maximum number of atoms. So using these criteria, which compound we selected? Fe3O4. Okay, and the element. And if tell me, if you are in this compound also you are selecting a particular element, then oxygen. If in this complete compound I am selecting the element, so that is oxygen. So element oxygen in it. So there are four oxygen atoms on the right hand side. And what was our reaction? What was our reaction? Our reaction was like Fp plus H2O. Our reaction was Fp plus H2O will give you Fe3O4 plus H2. This was our reaction, right? This was our reaction. So here, let us revise once what we discussed, and then we will see its application part. So it is convenient to start balancing with the compound which is containing maximum number of atoms. For example, in the above reaction, our Fe3O4 was containing the maximum number of atoms. So that we have to select. And again, what I told you, that may be a reactant or it can be a product. So in that compound, select the element which has the maximum number of atoms. Understood, Jason? Hmm. Yeah. Yeah, of course, four oxygen. So then how you will balance? See, to balance the oxygen atoms. So here to balance the oxygen atom, what we have to do? So initial situation, firstly we will write here initial situation. So initial, then atoms of oxygen, if I will see particularly here, initial, then to balance. In the reactants, how many atoms of oxygen were there? Only one. Can you see? Only one. As in my H2O, there is only one oxygen. And in the product side, what I can see here? How many oxygen are there in the product side? Tell me. Four. So that I have to write. Okay. That I have to write. Four. Then to balance, what I have to do? As maximum were four, minimum were 1 in the reactant side. That means in the reactant side I have to multiply with what? I have to multiply with what? 4. Are you getting? So simply see here, now you will get more clarity. For example, they gave you to balance the oxygen atoms, we can put coefficient 4 as 4H2O and not H2O4. Simply what I did here, I simply multiplied here with 4. Getting my point? I simply multiplied here with 4. So at that case, is this balanced? Check it once. This one. Yeah, not yet. Means this is a partially balanced equation. Of course, here our oxygen is balanced. So, but other atoms also we need to balance. Means iron and hydrogen are still not balanced. Okay, so pick any of these elements to proceed further. Any of these means either iron or hydrogen you can pick. Then let us balance hydrogen atom in the partially balanced equation. Let's say we are just balancing hydrogen in this partially balanced means in completely balanced equation, the equation that has been not completely balanced. So to equalize the number of hydrogen atoms, simply to equalize the number of hydrogen atom, what we have to do? We have to make the number of molecules of hydrogen as 4 on the right hand side. So here, can you say 4H2O? So what do you mean by 4H2O? 4 into 2, 8. So how many hydrogen are there? Are you getting? 8. Yeah, totally 8. And in case of H2, how many hydrogen are there? 2. H2 na, total hydrogen 2. So this is, in order to balance the equation, we can do 2 into 4 na. So H2, if I told you, see, if I told you H2, then it is having how many hydrogen? Hmm. Then it was having 2 hydrogen, right? So one thing you tell me, 1 second. So in this partially balanced chemical equation, you have seen that we have Fe plus H2O will give you Fe3O4 plus H2. So here we can see that to equalize, here we can see to equalize the number of hydrogen atom, make the number of molecules of hydrogen as 4 on the right hand side. So here what I told you, here what I told you, how many number of hydrogen are there in the reactant side or in the left hand side? Total, totally it is 8. But here you can see in this H2, this H2 is there. So in the product side, how many hydrogen are there? There are only 2. Okay, so in order to balance, are you getting this point? Means here there are 8 hydrogen, but in the product side there were only 2. So what I can do here, I can simply multiply this 2 with 4. It will come out to be 8. Yeah, so that we have to put in the front. So that obviously previously we put in the front, 4 into 4 into H2O, we did it already. Okay, so here means previously we balanced what? Oxygen. So here we are balancing what? Here we are balancing what? We are just balancing the, yeah. So in case of H2O, in the front, we put what? 4. In case of H2 also, we have to do like this, 4. So it will come out to be 4 into 2, that is 8. Clear, Jason? Tell me. Yeah, right. Understood? In case of oxygen also, na, we did the same thing. When we balanced the oxygen. Now we also balanced here the hydrogen. Now here we have to balance the iron also. Iron also we need to balance. So examine the above equation and pick up the third element, so which was not yet balanced. So our equation became like this: Fe plus 4H2O will give you Fe3O4 plus 4H2O. This was our equation. Okay. So now we have to balance the third element. Which element is left yet unbalanced? Iron. So let's see its steps. So examine the above equation and pick up the third element which is not balanced. So you find that only one element is left to be balanced, that is iron here. So atoms, you have to simply make a table and in which you have to write the atoms of iron, in which you will mention initial and then to balance. In the reactant side you can see, in the reactant side you can see that initial, in the reactant side you can see that initial. How many iron are there? Tell me. Only one iron is there. In the product side, tell me how many iron are there in the product side? 3 iron are there. Good. 3 are there. Okay. So the place where number of iron are less, now I simply do what? Simply I did what? This is 1, this is 1, and these are 3. Okay. So simply I have to do what? 1 into 3. so that it will also come out to be 3. So check here. So means in front of this iron I have to put right here 3. Simple. In front of which iron I have to write 3, in which there are less number. There is less number, okay? Because here in the product side already you can see that 3 iron are there. But already 3 are there na here. But in the reactant side there was only 1. So means I have to multiply here with the 3. Any doubts? Yeah, good. So in this way we can simply check that this equation is our balanced. We can simply check 3 iron are there, 3 iron are there. See, this is 4H2O, means this 4 is multiplied with this whole. So 4 oxygen, it means 4 oxygen. In the product side also 4 oxygen, and here hydrogen 4 into H2. This is 8. Here also 4 into 2, 8. Balanced. This is the balanced chemical equation we can see here now. Now we will see here some equations are given here. Other some equations are given here. See, here in the bracket you can see some basic things, like in the bracket S has been written. So this is representing what? This is representing the physical state. So S means the solid. Here small s represents what? That represents solid. And here if in the bracket it is written G, then it represents the gaseous state. Okay, clear? So physical state, this is mentioning what? This S and this G, they are mentioning what? This is mentioning the physical state. So usually physical, underline this thing, usually physical states are not included in a chemical equation unless it is necessary to specify them. Understood? Understood, or any doubts in this point? Hmm. Yeah, it is liquid. Yeah, these are the three physical states of matter. Na? So accordingly. So sometimes the check this point. Sometimes underline this. Sometimes the chemical reactions conditions. There are some conditions in the chemical reactions. In some reactions that you will see. So sometimes the reaction conditions such as temperature, pressure, catalyst, etc. Actually, what is catalyst? Put a arrow and write here. That is a chemical substance. I am writing here. It is a chemical substance that increases the rate of a chemical reaction. Here, to increase the rate of a chemical reaction means what? To increase the speed of a chemical reaction. Means reaction will take less time to complete. It will proceed fast. It will proceed fast. That is what simply I. Basically, it increases the speed of a chemical reaction. So there are some catalysts in different reactions in the higher classes also. In class 11th, also you will study in chemistry. Class 11th, you will also study in chemistry that in some reactions the suitable catalyst is being used. So that suitable catalyst is doing what? That is simply increasing the speed of your chemical reaction, or simply I can say that it will take place in a less time. In some reactions in the class 11th, detailed organic chemistry is there. So in that you will study that there are some different catalysts. They are used in some of the reactions to increase their speed. So what is the point here that we have to focus on at this moment? That sometimes the reaction conditions like temperature, like pressure, like catalyst, etc., The chemical reactions are, they are indicated, these conditions are indicated just above or below the arrow in the equation. For example, you can see here, check, this is the arrow, this is the arrow which is showing what, this arrow is simply showing that my reactant that is going to form my product. Okay, that is going to form my product. So here in this arrow you can see that just above 340 has been mentioned. 340 atmosphere has been mentioned. So what is this atmosphere? This is the pressure, this is the unit of pressure actually. So pressure has been mentioned here. For example, in any reaction it is mentioned like 300 Kelvin, like above or below this arrow, so it is representing what, temperature. Kelvin, if in the Kelvin, then it is the temperature. Yeah, so these conditions, they can be represented just above or below the arrow which are for your reaction, so that is given here. So for example, they gave you CO2 plus H2O. This is a actually which equation? Photosynthesis reaction. You can write here in the arrow, just put a arrow and write there, this is the photosynthesis equation actually, photosynthesis. This equation is what? Photosynthesis reaction. Okay, photosynthesis reaction, you know that the plants, they prepare their food by their own in the presence of the sunlight, in the presence of the sunlight. And chlorophyll, chlorophyll, you know, that is a green colored pigment which is present in your leaf. Your leaf, they contain, that contain a green colored pigment, that is the chlorophyll, that is responsible for the process of photosynthesis. So you can you see here that conditions of your photosynthesis reactions are carbon dioxide is required, water is required, and sunlight is required. So these conditions has been mentioned. And what is formed in your photosynthesis reaction? Remember, glucose is C6H12O6, C6H12O6. And remember one thing, one more thing also, that your oxygen gas is evolved. Can you hear me, Jason? Your, yeah, oxygen gas is evolved in the photosynthesis reaction. Okay, oxygen gas, that is released, and glucose is formed. And raw materials for the photosynthesis reactions are carbon dioxide and water. Carbon dioxide and water, these are the raw materials. And sunlight is required, this is a condition that is required in the process of your photosynthesis. Understood? Next is the types of chemical reactions that we already discussed, but just have a quick revision. Types of chemical reactions, first you take their combination reaction. So combination reaction, for example, your calcium oxide that reacts vigorously with water it is reacting. So this is your, this is also called as your quicklime. Quicklime. Quicklime is your CaO, calcium oxide. This is also called as your quicklime, CaO. So when it react with your water that is your H2O, it is going to form your slaked lime. Very, very important reaction. Right in the NCERT, it is important. So what is our slaked lime? Yeah, CaOH twice. Okay, it is also called as your calcium hydroxide. It is also called as our calcium hydroxide. Plus here you can see heat is, see what they are representing here, they are just saying that calcium oxide reacts vigorously with the water to produce slaked lime, that is the calcium hydroxide, and that is releasing, and here large amount of heat that is released, heat that is released in the large amount, heat is released in the large amount here, heat is released in the large amount here. And what happened here, this is the combination reaction, can you see that this is combining with this water? So In this reaction, calcium oxide and the water, they combines. Question can come that how slaked lime is formed. So what will be your answer? Yeah, you will write that in case of the preparation of the slaked lime or formation of slaked lime, your calcium oxide that react with your water, and then you will write the reaction. So in this reaction, calcium oxide and water, they combine to form a single product, calcium hydroxide. Such a reaction in which, this is the definition right here in the NCERT, this is definition of what? Combination reaction, in which a single product is formed from two or more reactants, that is known as your combination reaction. Yeah. Next is given some few examples. Just see these also. Let us discuss some more examples of combination reactions. First, you can see that is your burning of the coal. Burning of the coal. That is carbon in the solid form. That is what? That is our coal. So when it is burnt, so obviously when it is burnt, so obviously our air is containing what? Oxygen. So O2. So oxygen gas. So G. So it will give you what? It will give you CO2. Next reaction I can see next reaction I can see here other examples. Formation of water from H2 and O2. Obviously here my H2 and O2, they are just combining with each other, only that my water is being formed. So in simple language, we can say that when two or more substances, so that substances, those substances can be my elements or the compounds. So what I am saying to you, when two or more substances, so those substances can be my elements, they can be my compounds. So they combine to form the single product. They combine to form the single product. So those type of reactions, I will call them as a combination reactions. Clear? So a large amount of heat is evolved. Underline this. The reactions in which the large underline this point. The reactions in which heat is released along with the formation of product. Right here, this is definition. This is the definition. Write in your NCRT the things and the definitions that I'm saying to you. Just underline those so that during revision it will be helpful. Okay. So what is the definition of exothermic reaction? The reactions in which, yeah, those type of reactions I will call them as the exothermic reaction, as the name itself indicating. Na, exo means something is releasing outside, something is releasing outside, something is releasing outside. Exo. So thermal word is related to what? Heat. Simple. So other examples of exothermic reactions that they are just mentioning, that is the burning of a natural gas. Some examples of these are the examples just right here in the NCERT. These are the examples of exothermic reactions. When you burn the natural gas, one mark question can come from here. What is natural gas? Methane. What is natural gas? Methane. What is the formula of methane? CH4. What is the chemical formula of our methane? That is our CH4. So when the CH4 is being burnt, obviously it will burnt in the presence of the oxygen. So methane plus O2 will give you what? That will give you carbon dioxide plus water. That will give you carbon dioxide and water, and again these two are in the gaseous state. So we also know that we need energy to stay alive. We know this thing. So from where we get this energy? So we get this energy from the food that we eat. So during digestion, what happens? Food is broken down into the simpler substances. During digestion, what happens? Food is broken down into the simpler substances. For example, rice, potatoes, and the bread, they contain what? They contain carbs. They contain the carbohydrates. So these carbohydrates are broken down to form the glucose. So this glucose combines with what? This glucose combines with the oxygen. So where it combines with the oxygen? It combines with the oxygen in the cells of our body and provides us what? Obviously, it will provide us energy. Clear? So This is what is the special name to this reaction, in which the glucose that will react with my oxygen, or it combined with my oxygen. I gave name to this reaction as the respiration reaction. Okay, so where this reaction has been given, just put a arrow in your NCRT and write there, it is a respiration reaction. Done. This is a, above we discussed the photosynthesis reaction, where the raw products or reactants were carbon dioxide and H2O. Here in the respiration reaction, carbon dioxide and H2O, they are the products actually. Can you see one thing? Can you see one important thing here? This reaction is just reverse of the photosynthesis. Photosynthesis reaction reverse. Can you see this thing? But carbon dioxide and H2O were the reactants in the photosynthesis. But glucose and oxygen were the products in the photosynthesis. But here they are the reactants. Are you getting now? Yeah. So this is what that has been mentioned here. So the decomposition of the vegetable matter into the composite is also an example of the, when decomposition is breakdown. So when the breakdown of my vegetable matter into the composite, so that is also the, in that reaction also heat is evolved, so that is also exothermic reaction. That is also the example of exothermic. Next is the decomposition. So here you can see a simple example. So this is our ferrous sulfate. Ferrous sulfate is what? That is FeSO4. Decomposition, as the name itself indicating, that is single reactant, underline, single reactant breaks down to give simpler products. This is a decomposition, name itself indicating. So for example, ferrous sulfate, when you heat this, it will get decomposed, it will get decomposed into the ferric oxide, that is Fe3O4 plus sulfur dioxide and SO3. So here let's read this point, no worries. So ferrous sulfate crystals, what are the ferrous sulfate crystals? That is FeSO4 associated with 7H2O. 7H2O, FeSO4 dot 7H2O. So these ferrous sulfate crystals do what? They lose the water obviously when heated, and the color of the crystals changes. Then if then this FeSO4 that is being decomposed, then it will give you ferric oxide, underline, then it will give you ferric oxide, that is Fe2O3. And again you will get here two gases, sulfur dioxide and sulfur trioxide. Right here, ferric oxide is a solid, that is a solid. But here we can see that our SO2 and SO3, they are our gases. Yeah. So next example, this is the first example that we simply, very easy, the water molecules which are associated with the FeSO4, that is the 7 molecules of water. So when we heat this these ferrous sulfate crystals, then obviously when something is being heated, it will lose water. And then once it has lost water, and then again if we heat it, then we will get at that case ferric oxide, that is Fe2O3 and SO2 and SO3. Clear? Very easy. So next is the decomposition of calcium carbonate. What is the calcium carbonate? Calcium carbonate is CaCO3. This is, these type of questions come in 1 mark or MCQs. This is limestone actually. Its common name is limestone. Hmm. Hmm. Yeah, good. That is slate line. So, so these three are important. Yeah. So decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating, when we heat it. This is an important example of the decomposition reaction used in the various. This is very easy actually. Na? From the reaction itself we can see it very easy. CaCO3, when it is heated, carbon dioxide is released. So if carbon dioxide is released, how many oxygen are left? Only one. So Ca. So calcium oxide is also called as the lime or the quicklime. It has many uses. Underline this. It has many uses. But right in the NCERT, this is the use. Just put a arrow and write. This is the use of. This is the use of. Hmm. This is the manufacture of cement. So when the decomposition reaction is carried out by heating, obviously very easy, thermal decomposition. Thermal means heat. So when the decomposition reaction that is carried out by heating, then it is called as thermal decomposition reaction. Then we will call it as the thermal decomposition reaction. One important activity has been given here. This is important. So see, take about 2 gram of lead nitrate powder in a boiling tube. So then in the image also it has been shown, in a boiling tube you took what, about 2 gram of powder of lead nitrate. Then hold the boiling tube. Simply you are holding this boiling tube, and this is a burner here, and you are just doing what, you are just heating it. Okay, you are just heating it. You will observe one thing, and this observation is important. From here question comes. Underline this, very very important. You will observe at that case the emission of the brown fumes, and these fumes are of NO2. Very very important. First question is, which colored fumes you will you will observe here? Which colored fumes you will observe here? Brown. And these fumes are of what? Very important. Yeah, very easy and important also. Heating off, simply just imagination. Just imagine the things. This is a tube. Here you took what? You took the lead nitrate, and simply you have just put the burner here. You are just holding this tube. You are just holding this tube, and here you can see that there is the emission of the nitrogen dioxide. It's brown fumes. Clear? So here complete reaction, we can see how the complete reaction that proceeds. Just enclose this reaction in a box. This is how it is being take place. Complete reaction. See what happens actually when you just took the PbNO3 twice in a tube. That is your lead nitrate. This PbNO3 twice is my lead nitrate. Clear? And when I'm just heating it, at that case I will get what? I will get here lead oxide. Lead oxide. Firstly, I will get here lead oxide. That is my PbO. Tell me, tell me, brown colored fumes I told you, and which oxide? Of which oxide? Yeah, plus O2 gas is evolved. So this is the complete reaction. And here in the NCERT you can write one thing, brown fumes here, just below this, so that you will never forget. Clear? Everything up to this? So here you can see a yeah, underline this. You will see from this point, white silver chloride turns gray in sunlight. White silver chloride, underline from here. White silver chloride. Silver chloride is what? AgCl. AgCl. AgCl turns gray in the, this is having white color. This was having white color, and in sunlight it will turn gray. Why? See, this is due to the decomposition. This is also the example of the decomposition reaction. This is also an example of decomposition reaction. So this is due to the decomposition of my silver chloride into what? Into my silver. First one I will get here silver, second one I will get here chlorine, second one I will get here chlorine. Clear? Jason, clear? Hmm. Yeah, by the sunlight. Very, very important. Okay. So here in this reaction, you can see Cl2, chlorine you will get. So also remember one thing, silver bromide also behaves in the same way, same type of reaction in the sunlight. Okay. So AgBr also in the presence of sunlight will get decomposed. Here also decomposition reaction you can see. But here you will get bromine gas obviously. So the above two reactions are used in the black and white photography. Very, very important. Black and white photography. Very important. Yeah. Okay. So this is what we discussed. So next is the underline this, the decomposition reactions require energy. The decomposition reactions require energy either in the form of the heat, either in the form of the heat. Decomposition reactions, they require what? They require the energy. And now here the question arises that from where this energy will come. So either in the form of the heat, light, or electricity. So obviously for breaking down the reactants, obviously for breaking down the reactants, energy is being required, energy is being required. Okay, so from where this energy will come? This energy will come either in the form, these are the conditions you can see here, for example sunlight, or you are simply heating. So these are the conditions. Okay, in this reaction also, see, in the above reaction also you have seen one thing, you have just seen heat. So what I'm saying to you here, that decomposition reactions, they require the energy either in the form of the heat, light, or electricity. Yeah, for breaking down the reactants. The reaction in which the heat is absorbed, underline right here, this is the definition of what? Endothermic reaction. So the reactions in which energy is absorbed, they are known as the endothermic, just opposite to the exothermic. Clear, Jason? Next they have given, that is the double displacement. So here we can see one thing. So one reaction you can see here, displacement. So this is the example. So right here, this is the example. So iron Fe plus CuSO4 in the aqueous solution. What is the aqueous solution? Right in the NCERT, when the solvent is water. For example, now if you are mixing anything in water, then at that case you can say that your solvent is water. So that is the aqueous solution. So CuSO4 copper sulfate, obviously displacement reaction. How displacement will take place here? You can see that in this reaction iron has displaced or removed another element, copper, from the copper sulfate solution. Okay, from the copper sulfate solution, and again that solution was the aqueous. Here solvent was water. So here iron has, underlined this, here iron has displaced or removed another element. Which element? Copper. From what? From the copper sulfate solution, means from CuSO4 solution. And this reaction is known as displacement reaction. Clear? So here you can see one thing, Zn plus CuSO4 in the aqueous solution of it, that gives us ZnSO4, and again this is displaced. In the zinc also same thing. In case of zinc also same thing. So here you can see one thing. This is the lead. What is lead? Pb plus, when it reacts with the copper chloride. So what is my copper chloride? CuCl2. CuCl2. So it's aqueous solution. So again I'm seeing what I can see here, that again again here copper is being iron. Here in the first one we just saw iron has displaced copper. In the second one we just saw zinc has displaced copper. In the third one lead has displaced copper. So why this is happening? Why this is happening? Because why they are able to displace copper? Why they are able to displace copper? This is the important question. Because zinc and lead, they are more reactive. Obviously, they are more reactive. For example, in any competition, your friend displaces you. So how your friend will displace you? Because he or she is having more number of marks. Same way you can remember here that zinc and lead, they are more reactive, so that's why they displaced copper from the solution. Clear? So double displacement, next is the double displacement reaction. So underline this: white substance which is insoluble in water, which is formed, that is known as the in this activity you can see, for example, take 3 ml of sodium sulfate solution in a test tube. 3 ml of the sodium sulfate. What is sodium sulfate? Right here, Na2SO, Na2SO4, Na2SO4. So you took what? You took a test tube. See here, you took a test tube, about 3 ml of sodium sulfate solution you took here, and this is the another test tube you are just holding, and here you took same amount of barium chloride solution. What is barium chloride? BaCl. So at that case, what you will just mix these two solutions. You will just mix these solutions. Very important, right? IMP. You will notice that a white substance is formed here, and that white substance, that is insoluble in water. So this insoluble substance which is formed here, that is known as the precipitate. That is known as the precipitate. And any reaction that produces a precipitate, that is called as the precipitation reaction. Right here, this is the definition. This is the definition of the precipitation reaction. Okay. So here you can see one thing. This is the complete reaction you can see. This is Na2 double displacement now. Na2SO4 plus BaCl2. In the aqueous solution you can see. Here water also being taken in this test tube. So that's why this is the aqueous in the aqueous solution. That's why in the bracket AQ is written plus BaCl2. So here what will happen? This SO4 will come with this Ba, and again so NaCl. So white precipitate of BaSO4 is being formed here. BaSO4, right, put arrow and write its white precipitates are being formed. White precipitates. So they are formed by the, because here ions are what? Ba2 positive ions, that is barium ions. Barium ions. Next is the SO4 2 negative ions. These are our sulfate ions. So the other product formed is the sodium chloride. NaCl is also being formed here, so which remains in the solution. But PPT of BaSO4 are being formed. So such reactions in which there is an exchange of ions between the reactants. So that is the double displacement reactions. Underline this. Reaction in which there is the exchange of the ions between the reactants, that is the double displacement reaction. So Jason, we have just completed this chapter na. Only oxidation reduction I told you in the last class, and oil rig trick also I told you, right? So in the next class, just in 1 2 minutes, we will revise this, and we'll do last topics, corrosion, rancidity, and this chapter will be finished. Okay, and we will do some question discussions, and then we will proceed towards the next chapter also.